So let us see this example, integral of 1 over root 5 minus x squared d of x. If we said, for example, I want to use the u-substitution, and you choose 5 minus x squared is equal u, then once you differentiate, it will be minus 2x du is equal minus 2x d of x. You have dx here, but you don't have x. So from where you will bring x? So for these rules, you will use one of these three. Here you have a square minus 1 over root square a square minus u square. So here we have 1 over root of 5 minus x squared. So we will use the rule 1 over root a square minus u square du is equal sine inverse u over a plus the constant c. But first, here we said 5 minus x squared. We need to specify what is our a and what is our u. So from here, our a is equal root of 5, because here we have a square minus u square. Here we have 5, so this is a square. So what is a? A will be equal root 5. Then minus u square, so here we have minus x squared, so u is equal x. So the integral of 1 over root 5 minus x squared d of x will be sine inverse u over a, which is x over root 5. Then we add the constant c. Then we have the integral of 1 over 1 plus 25 x squared d of x. Again for this one, if you choose for example 1 plus 25 x squared as u, then once you find du, it will be 50x d of x. You have here d of x, but you don't have 50x, so you cannot find the integration. So we use that rule, integral of 1 over a squared plus u squared du is equal 1 over a tan inverse u over a plus the constant c. But first we need to rewrite our function 1 over 125x squared as a squared plus u squared. So if we take 25 as a common factor between these two, it will be 25 multiplied by 1 over 25 plus x squared. So from here 1 over 25, which is this one, is a constant. So we have integral of 1 over 25 plus x squared. So from here our a is equal 1 over 5 and our u is equal x, because this one represents a square, this one represents u square. So a will be 1 over 5, u will be equal x. Now we have 1 over 25, the integral will be 1 over a, so it will be 1 over 5, tan inverse, we have u over a, so it will be x over 1 over 5. Then we add the constant c. So this is 1 over 25, 1 over 5, this is 5 tan inverse, x over 1 over 5, this is 5x, plus the constant c. So the integral will be, if we cancel 25 and we take here 5 from here, we get 1 over 5 tan inverse 5x plus the constant c. Then we have evaluate integral of tan x d of x. So we know that tan x is equal sine x over cosine x d of x. So we need to find the integral of sine over cosine. If we assume u is equal cosine x, then du will be equal, derivative of cosine will be minus sine x d of x. So from here we will get, here we have sine x d of x, but here we have minus sine x d of x. So we need to take this minus to the other side, so we have minus du is equal sine x d of x. Now we can replace sine x d of x by minus du, replacing 1 over cosine x by 1 over u. So the integral of minus 1 over u du will be minus ln absolute value of u plus the constant c, where u is equal cosine x, so this will give us minus ln absolute value cosine x plus the constant c. Sorry for this mistake, this is not d of x, this is minus ln cosine x plus the constant c. So this one should be plus c, not dx, because we finished the integration, so this is will be plus the constant c. Then we have evaluate integral of sec x d of x. So integration of sec x, we cannot simplify this function, but we have to manipulate this function to put it easy for us. So we will multiply this function by sec x plus tan x, and we will divide by sec x plus tan x. Sec x plus tan x, sec x plus tan x, this is give us 1. So we multiply this function by 1, by multiply by sec x plus tan x, divided by sec x plus tan x. So now if we multiply sec by sec x plus tan x, this will give us sec square plus sec tan. Then this is over sec x plus tan x. Now we need to use the u substitution to find the integral of this function. So if we assume u is equal sec x plus tan x, if we take this one as u, so then du will be equal the derivative of sec x will be sec x tan x plus integral of tan x will be sec square x d of x. So here we have u, so now we can replace sec x plus tan x by u. But what about sec square plus sec x tan x d of x? We can replace it by this one, which is all of this du. So sec square x plus sec x tan x dx, it is just du. Sec x plus tan x, it is 1 over u. So we have integral of 1 over u du. This is ln absolute value of u plus the constant c. Now we will replace u by what we assumed from the beginning, which is sec x plus tan x. So the integral of sec x will be ln absolute value sec x plus tan x plus the constant c. So for this function, we don't use the substitution, we don't use the rule. We just multiply our function by sec x plus tan x, divide by sec x plus tan x, then use the substitution, then we find what is the integral of sec x. Then we have the integral of cosine 5x all squared d of x. We know that cosine square x is equal half 1 plus cosine 2 of x. So cosine square 5x, this will give us half 1 plus cosine 10x. From where we get this 10? Because if it is x, here we have cosine 2x. So if it is 5x, so we should multiply this one by 2, we'll get 2 multiplied by 5, so this is 10x. So now the integral of cosine square 5x d of x will be integral of half 1 plus cosine 10x d of x. Half is a constant, so we take it out. Now the integral of 1 plus cos 10x d of x. Integral of 1 is x plus integral of cosine 10x will be sine 10x. We divide by 1 over 10. Here we use the u substitution. We assume u is equal 10x. Then du will be equal 10 d of x. Since we don't have here 10, so we need to write du over 10 is equal d of x. So that's why here we get 1 over 10 sine 10x. Then we add the constant c. So half multiplied by x will be half x. Half multiplied by sine 10x over 10, it will give us 1 over 20 sine 10x plus the constant c.